inequalities. An inequality is a math sentence that compares quantities that are not equal. Inequalities have the following symbols. An inequality symbol is any of the following: less than, greater than, less than or equal. That's a less than symbol with a line underneath it. And finally, greater than or equal. That's a greater than sign with a line underneath it. Some other phrases or words that represent these are also listed in this chart. We will refer back to these later. Let's start by writing an inequality to represent each scenario. First, we will write a let statement to define our variable that we're going to use, and then we can use the keywords in the chart on the previous slide to determine which inequality symbol we will need to use. For the first example, if the account balance is more than $50, we want to use a variable to represent the account balance. So we'll say let B equal the account balance. And the key word in this is more than, which means greater than. So our inequality is B is greater than 50. This next example says the temperature is less than or equal to 34 degrees. We will let T equal our temperature, and our keyword or words are less than or equal, which would use the symbol as shown down here below. T is less than or equal to 34. The hourly wage for babysitting in a certain community is at least $4.25. Our key word here is at least. This tends to be a tricky one because we see the word least and we are drawn to say that it's less than or equal to. But actually, if we are saying that something needs to be at least $4.25, that really means that we want it to be $4.25 or more. So in this case, we're going to use the greater than or equal to sign to say that W, the hourly wage, is greater than or equal to $4.25. Here's a few for you to try on your own. For this first one, you would say that X, the number of quiz questions answered correctly, is at most 25. That means less than or equal to 25. For the second one, if there are more than 5 members in Jack's family, that is X is greater than 5. And I'm just using X for all of these, but in whatever letters you used are fine as long as you define them as what's missing. So in the first one, the number of questions answered correctly, and for the second one, the number of members in Jack's family. For the third one, X is the amount Angela earns. It says she earns no less than 10 per hour is greater than or equal to 10. And for the last one, John owes his friend more than $80. That's greater than 80. A solution of an inequality is any number that makes the inequality true. If we look at an inequality, let's just take, for example, X is greater than 5. X is going to be representing all of the numbers that would make that inequality statement true. How many numbers could we replace X with to make that statement true? How many solutions are there? In an inequality, there are actually infinite number of possible solutions, because we are looking at how many numbers are there that exist that are greater than 5. Well, there are an infinite number of numbers bigger than 5. When we solve an equation, or when we look at an equation, we're saying x equals 5. That's it. Nothing else. X has to be 5 to make it true. But with an inequality, there are infinite numbers that can make that statement true. So let's just take a look at a couple inequalities, and let's see if these possible solutions make this statement true or false. So for this first one, is 3 greater than 4 times a minus 9 if a equals 2? So if a was 2, 4 times 2 is 8. 8 minus 9 is negative 1. Is 3 greater than negative 1? Yes. So that is a equals 2 is one of the many solutions for this inequality. It's not the only one. It is one of the infinite possible solutions. For the second one, is 120 one of the solutions to the inequality x divided by 6 minus 2 is less than or equal to 8? (120) divided by 6 is 20. Minus 2 is 18. Is 18 less than or equal to 8? No, it is not. So 120 is not a solution. Take a minute to answer this question. Which of these following solutions is a solution to the inequality? 1, 2, 3, or 4? If you said 4, you are correct. If I plug in 1, 2, or 3, 1 and 2 would give me answers that are less than 17. 3 would give me exactly 17, but I don't want 17. I want it to be greater than 17. So 4 is the only one that will make my answer greater than 17. Since there are infinite possible solutions to an inequality scenario, instead of writing out all of the possibilities, which is not possible, what we do is we graph or draw them on a number line. This just takes care of all of the possible solutions, and it shows in which direction or where on the number line are the numbers that make that inequality statement true. And we'll come back to this in a moment, but what we want to make sure we do is we want to always write our inequality so that the variable is on the left-hand side. So like x less than or equal to 3. And I'll show you an example of how we can do that in a minute. But first thing we need to know is when I'm graphing this on a number line, I'm going to start by putting a dot on or above the number that's in my inequality statement. Now, since we have different types of inequality symbols, we have to have different types of dots that indicate which inequality symbol I will be referring to. So for the less than symbol and the greater than symbol, we use what's called an open dot or an open circle. That would mean that, for example, if x is less than 3, I would be using all numbers that are less than 3, but not 3 itself. So this, although our circle will be on the 3, which I'll show you in a moment, it's not actually going to include the number that the dot is on. So this means that it does not include the number that the dot is on, but it's everything up to that number. For our less than or equal and greater than or equal, we're going to use a shaded in or a colored in dot or circle. This means, for example, if it was x is less than or equal to 3, I could actually use 3 as a solution because it says x is less than or equal to. So this means that it does include the number that the dot is on. So let's take a look at a few examples of how can I show my inequality solutions on a number line. So if C is supposed to represent any number that's less than 4, when I draw my number line, I'm going to just number, I always like to put the number that's in my inequality right in the middle, so the 4, and then I usually just put 1 or 2 numbers on either side. So 5 and 6, 2 and 3, you do not need to number the entire number line. Just 2 or 3 numbers, or 1 or 2 numbers on each side. So now what I'm going to do is I'm going to put a circle on the number 4 because that's my reference point. But since it's less than 4 and not equal to 4, I'm going to use that open dot or open circle. And then to show that C is every number less than 4, I'm going to draw an arrow in the direction where all of the numbers that are less than 4 are. So in this case, that's to the left. If you notice, my less than symbol sort of points to the left, and so does my arrow on my number line. Let's try another example. H is less than or equal to -3. So again, I take my reference point, which is -3, and I put that right in the middle. And then I'm going to put 1 or 2 numbers on either side. Be careful when you're numbering a negative number line. Make sure that you're numbering it in the correct order. Remember, negative numbers look higher as they go to the left as we get farther from 0. Since this is less than or equal to -3, that includes -3 as a possible solution. So I use a closed or shaded in dot. And then to show where all of the other numbers are that are less than -3, I'm going to draw that arrow to the left again. So again, since it's pointed to the left here, I draw my arrow to the left. Okay, looking at this one looks a little bit different because as you can see, the G, the variable, is on the right. So -6 is less than or equal to G. What I would like for you to do before you graph this is to rewrite the inequality so that the variable G is on the left. When we rewrite it, we need to make sure that the right parts of the inequality symbol are still facing the correct part of the inequality. So my open part of the inequality is facing the G, and when I rewrite it, I need to make sure that that is still true. So when I rewrite this, it's going to look like this. G is greater than or equal to -6. So the open part of my symbol is still facing the G, where the point is still facing the -6 like it was in the original problem. So I'm reversing the entire thing so that when I graph it, my arrow in my inequality symbol is going to face the same direction as the arrow on the number line. If I don't rewrite it, then that is not true. So start by numbering your number line, put that -6 right in the middle. Since this is greater than or equal to, I'm going to use that closed dot again. And then if it's everything bigger or greater than -6, that is going to shade to the right. So that matches the direction of the inequality symbol after I rewrote the problem. If you look back at the original problem, you can see that it does not match the direction of the inequality symbol in the original problem, and that's because the variable was on the right instead of the left. So it tends to be easier for most of us to rewrite it so that the variable is on the left, and so our arrow matches the inequality symbol direction. Here's a few for you to try on your own. For this first one, we're going to put the -2 right in the middle, and I'm just going to put one number on each side here, and that's plenty. Since it's greater or equal, I'm going to put a closed-in circle or dot above the -2, and my arrow should go to the right. For the second one, I'm going to put the 9 right in the middle, and one number on each side. This is less than 9, so that's an open circle because it doesn't include 9, and my arrow goes to the left. All the numbers less than 9 are to the left. With our last example, the r is on the right, so before I graph it, I'm going to rewrite it. Instead of 4 is greater than or equal to r, I'm going to say r is less than or equal to 4. So that's going to give me a closed circle above the number 4, and my arrow is going to go to the left.